All right, great.
All right, ladies and gentlemen, Riaz Virani.
Hi, everyone. Hello. All right, so I'm here to tell you about how you can use JavaScript everywhere. A little bit about me. My name is Riaz Virani. I'm CTO / lead developer / technology corraller at a startup called LoadUp Technologies. We build really interesting software. It's waste management software for people in the construction industry. It's awesome. So anyways, the goal for today is really to inspire you to think about looking beyond the browser box and begin building crazy things with JavaScript. So I'm assuming most of you are JavaScript developers or looking to become JavaScript developers. How many of you use JavaScript in some context right now that is not inside the browser window? Like not for, great, OK, maybe about half of you. So you're probably using it for a couple of things. I'm here to tell you you can use it for about 20 more things, and you should. So first, let's admit what sucks, right? The language can kind of suck sometimes, right? JavaScript, in some ways, if you look at it, it was made many, many years ago in a couple weeks, and it has a lot of idiosyncrasies that don't make any sense. For example, empty array plus empty array equals empty string, or the value of WTF. We can't even agree on what to call the language sometimes, right? So we have ES pick a number. We've transitioned from ES6 to, which was, I guess, ES 2015 that we're starting to implement. But then there's ES7, which I guess would be ES 2016, which is not really being implemented or is being is thought as being too far in the future. We also have a problem of too many libraries sometimes, right? There's a lot of churn in sort of the libraries people use. There's problems with stability and maintenance. And we have the shiny things problem, right? You can say there's this a problem in many languages, but I'd say it's probably uniquely bad in JavaScript. In fact, it's so bad, I'd say that a lot of us have this problem where we really get excited about a new framework or tool, and then immediately, just within a couple weeks, we'll have this problem of immediately regretting our decision. Again, something that happens in most languages is probably uniquely bad in JavaScript because of the nature of the ecosystem. So I want to pause, though, right? We can shit all over JavaScript as much as we want, but it doesn't matter. Something incredible is happening in JavaScript, and I would say we have to pay attention or it's going to pass us by, right, as developers. So this is kind of what inspired the talk. It's actually a talk by a guy named Scott Hanselman, and if you could indulge me, I'd love to play about a minute of a clip that really blew my mind and inspired me to even give this talk. Hopefully the audio works.
So I started exploring about all the crazy stuff folks are doing in JavaScript, and I noticed that there's this gentleman here who is insane. This is an implementation of Linux that's running entirely in JavaScript and emulating an x86 processor as well. This is real. You can tell because you right-click and it doesn't say Flash, because if you right-click and it says Flash, you're like, cheater. And then I could go like at the command line here and then actually compile with an open source C compiler, hello world. But that's cool, but it's not deeply cool. What would be really cool would be opening up an iPhone simulator and then opening up mobile Safari, and then inside of that, then going and running a JavaScript virtual machine on a Windows machine. So I mean, that would be because internet.
All right, so maybe some of you that went really fast and grasped what happened, but that blew my mind, right? Like I feel like we've entered the singularity now. We can now run a full x86 machine, or at least significant parts of it, inside a browser, and you're literally running Parallels Desktop inside of a browser window, right? Think of the levels of inception you can go to. But so that made me think that maybe the glass is half full, right? Maybe being down on JavaScript is actually not the right way to think about it. The ecosystem is actually amazing with the number of people that are contributing to it, the number of people that are vested in it. And you can call this chart bad, but you can say it's open source glory. I'd say many languages who are really starting out or even mature would love to have this number of contributors and this number of companies contributing open source to making the entire ecosystem better. And this is another chart that blew my mind. This is a chart of essentially all of the various package managers for different languages. And if you look at the green one that's clearly beating all of them, that's NPM, right? Since 2014, you could say that the contributions and the community engagement is really unsurpassed in the JavaScript community compared to other languages. And apparently, I would say, you can say some of it's crap, and it is, but a lot of it's very useful. So it's kind of harmonized on what we could call Atwoods Law. How many of you have heard of Atwoods Law before? Okay, so Atwoods Law was essentially a thing thrown out by a famous developer on his blog, Coding Horror, which I encourage all of you to read if you do not. And he said that any application that can be written in JavaScript will eventually be written in JavaScript. And this is, again, what I'm talking about, sort of that singularity notion, right? That it's becoming more and more that you can use it outside of the browser for production-ready, battle-tested SDKs and libraries to build all sorts of stuff. So, well, that's not good enough. Let's prove it, right? You know, what if we had to build something simple? So we can build a simple daily calorie counter. The counter showed us how many calories we eat in that day, so it's just a number for the day. And then depending on the client, we can have a button or some way to increment the calories or decrement the calories, right? Simple enough, fairly useful. A nice simple calorie counter for all of those of you that are really frustrated with the really complicated calorie counters out there. And let's see what we can do with it given these rules. You can only write JavaScript. You can use any JavaScript SDKs that interface or translate to other languages, but your knowledge, your code, everything has to be JavaScript. We can write shitty code. We're spiking it right now. We're not really trying to write something that we're going to roll out for real. And it must be relevant to our requirements. Again, whatever we build has to be relevant to those requirements of building calorie counter. So this is the part where I'm going to show you a bunch of demos of really crazy stuff. And smart people don't do live demos, but I'm not very smart, so I'm going to do them anyways. So the first one we're going to start out with is what you would already expect, right? Cool website stuff. This is what JavaScript was built for. It's what it should be able to do. We're going to be using React in this construct. And it's a JavaScript framework invented by Facebook. Most of you, I'd imagine, have heard of it by now. It's used by a lot of big companies. It's awesome. And we're also going to be looking at Chrome extensions in a second. Those are the add-ons to Chrome that make it more useful. Those are essentially these little things in the top right, if you know what I'm talking about. Some of you might have thought that those are written in some complicated language. They're just JavaScript. They're just little web pages, actually. And we'll see how easy they are to build. So first of all, let's go to my little dashboard. All right. So I wrote my little dashboard. It's cutting off at the bottom, but I've eaten 1 calorie for today, and this is connecting to a real website connecting to a real API. So if we bounce over to the code real quick. So those of you that aren't really familiar with React, some of this may look a little bit foreign. Oops. But we'll try to keep it fairly simple. You only have to really understand the basics, but this is also the simplest use case, right? I'm using Firebase, by the way, for a lot of these backends just because I wanted to play with Firebase, and it was really easy. For those of you that don't know, Firebase is essentially a backend as a service that serves as a database layer. Yeah. Can you turn the font size up a little? Yeah, absolutely. That's a good idea. Better? OK. So only thing you really have to know is that in React, the brains of the operation that shows you what's in the page is in the render function. So all we're doing here is this first part will show loading if we haven't got any data yet back from our API call. And then this part just renders kind of what you saw. It says Riaz's calories. We're binding this variable called visible calories. We're showing it on the page, right? All in all, about 50 lines of code. We've got a quick web dashboard. Not that crazy yet. Well, let's jump back over here. Let's look at Chrome extensions, right? So as I told you and promised, Chrome extensions are nothing crazy. They're simply just a very simple web page and with a manifest file that lets you declare how it's going to be used and get the permissions to access the parts of the page that you want. You could definitely write one in a couple hours if you know a little bit about JavaScript. So if we look at Chrome, pop open the code, but I'm going to show you real quick. We built a little Chrome extension that hooks up to the same API. It's a little button right here on the top right, if you can see. It's a little plus icon that I added. So if I hit that, voila. It's, again, 1 calorie. I can hit the plus button here, 26. And if I jump over here, these should stay in sync. Boom. Magic. OK. Well, the code for that turns out to be just as simple, right? So at the top, there's some utility functions I wrote. I'll make it a little bit bigger. That you don't really have to worry about, but they're just really boilerplatey things that connect to Firebase, let us set calories, let us retrieve calories. But this is really the logic of all of it. We get to the Firebase reference. Order by key limit to last means let's get today's value because it's the very last day. And then we bind to the change in value, and we call bind calories in Firebase. And when we click the plus button, we add calories. And when we hit the minus button, we subtract calories. All in all, again, about 50 lines of code to build something useful in a context that you could say is semi-browser-ish, but not truly. Any questions so far? Yeah. So hitting the plus button is connecting to Firebase, which is making the change in Firebase, and Firebase is broadcasting changes out to the web page. So the way Firebase works is it's very similar to the way WebSockets kind of would work, but the way it works is that the browser is subscribed essentially via a socket, and then it's firing the callback function whenever there's new data on the Firebase server. Good question. All right, server stuff. We still haven't gotten to the really fun stuff, by the way, obviously. Node.js, so it looks like the vast majority of you have experience with. I'd imagine all of you know about it, but this is really the brains of what's really let JavaScript explode, right? It's this notion that we can take JavaScript and run it somewhere that's not in a browser. And it's being used all over the place, and it's fantastic, and you should learn it. But I'll move on from that. So Node.js, let's go to a really simple use case, right? So we're doing a little bit of a relay action here because we're going to very similarly, again, require some stuff. And then line 11 through 20-ish, we're using some utility functions to mess with Firebase. And this is a very simple Express server that, in reality, if you look at it, line 41, we're listening to a post call to /calories/today. And then we do some stuff, and we're essentially going to add those calories to the current day's worth of calories. So I guess we can use Postman for this if my dyno hasn't fallen asleep. So if you don't know what Postman is, it's just a tool that lets you make API calls really similarly. We're calling my little Heroku app, health tracker node, to herokuapp.com/calorie/today. Our body is calories1. Let's make it something more. Currently, we are starting with 126, so this should be 226. But the dyno went to sleep. Should have paid. Oh, yes, succeeded. 226. Yay. OK. All right. Now we get to have some fun. So we're going to talk about how you can control this thing and other voice assistant devices through JavaScript. How many of you know what either of those devices on the right are? The Amazon Echo, the Google Home. How many of you have one or the other at home? OK. You should get one. So Google Home, which is this thing, it's sort of a copy that they made of the Amazon Echo. It's an always-on personal voice assistant. You can just talk to it anytime. And they released an SDK in December. What was really the only language they launched when they released? JavaScript. And the Alexa, right? The Echo, which is the back end to that, the service is the Alexa. It's backed by Amazon. They released really only one SDK if you wanted to play with it, and you run it on Lambda. It's also JavaScript. Like the first priority, like the tier 1 language these guys are supporting is JavaScript. So it's pretty easy to control. npm run preview. And it's pushing, and it's pushed. OK. OK, Google. Talk to health tracker. Oh no, the Heroku dyno died, the other one. Come on.
Sure, here's the test version of health tracker.
Hi, I can track your calories. How many calories did you eat?
150.
Recorded 150 calories.
Right. So I kid you not, that was, again, pretty easy, actually. Now, it'll look a little more intimidating. Oh, wait, did I open it? All right, let's start closing some of these, because I got too many open. There we go. All right, so I'll compress this. So the way it works is that we're essentially, with the command line thing I did, we're telling them, for my personal account, that I want you to register, essentially, that when I say talk to health tracker, I want you to call this API, this endpoint, right? And that endpoint is run on Heroku right now. It's just a little Heroku app. And so on Heroku, I'm running another little Express server. So again, at the top, we require some stuff, as you might expect. We have some functions, again, that just let us connect to Firebase, update calories, get calories. And then down here, we have really our one endpoint. And what we're doing here is we're using their library that they offered, the Actions SDK Assistant that you see on line 36. I'll make it bigger. And then you have to use a little bit of a complicated syntax, but it's not super complicated because you can see like input prompt, build input prompt. I can track your calories, how many calories you eat today. Ask this, and then the next thing is the input to it, where if I said bye, say goodbye. Else we want to, if we have some calories, get the current date string and get the existing calories, add the existing calories to the new calories, update it in Firebase, and then say back that we recorded the calories. So again, all in all, like 75 lines of code, something that most of you could bang through really quickly if you just get a little bit familiar with the SDK, and you can build real stuff. You could build really complicated stuff if you wanted to with all of this. That was pretty cool, right? Yeah. Well, there's more stuff coming. So desktop stuff. This has sort of been the area where if you look at it most of the time, people get super scared because desktop is like sort of Microsoft and Cocoa, and it's really hard. It takes a lot of time to learn and invest, and you never have any cross-pollination with web developers who think of themselves as, no, let's build a web app because we want it to be cross-platform. Well, we have the web, and therefore the web has gone to the desktop, and therefore you don't have to actually learn any of that desktop stuff, or most of it anymore. So we're going to talk about Electron. Electron is a framework to write desktop apps using HTML, CSS, and JavaScript. And it's not a small fry. It was invented by GitHub. It's what Atom, the code editor, if any of you use, like you are running Electron. Visual Studio Code, the new Microsoft editor, it's getting a lot of popularity, written in Electron, or I guess a variant of it. Postman, the app that we just tried, written in Electron. The Slack app, written in Electron. It's absolutely fantastic. And then just for fun, we're going to look at a little tool called AnyBar, which is a little Mac notification utility that's just sort of really cool, and I'm going to show it to you. So, all right, Electron, I promise you, again, that's a real thing. The documentation is absolutely amazing. You can do all sorts of stuff with it. It's got a lot of good stuff out there. It's not a small project. Let's do a demo. OK. I think it's a script. Yes. OK. Yay. Now we got a desktop app. And it is actually running as a real desktop app. I didn't change the icon. But I can do this. And this is, like I made it look very similar. But yeah, this is actually doing the exact same thing. So the code behind it, it's all in this one file, popup.json. So it'll look very familiar. We have some utility functions to kind of just help us connect to Firebase, get calories, set calories. And this looks almost identical to that Chrome extension, right? That's because it pretty much is. I mostly copied and pasted the code. But it was cool to me that I can now run it in a desktop context. And by the way, you get access to all of the desktop APIs. You can access camera, audio, all of that stuff. And there's really good libraries to be able to do almost all of that. Oh, one more thing I wanted to show you. This is something that one of my coworkers showed me that I still to this day do not believe is actually true. They've gotten so good at this, they can take any website and wrap it in a native app on demand, and you can just use it. So someone throw out a website. Reddit? Yes, you can just do. So I'm calling native fire down at the bottom, and native fire is it's a tool someone made. Make any web page a desktop application, and you basically call native fire and then the website, and it gives you a desktop app of that website. So we'll try to see if we can run it on Reddit. All right, so it looks like it's built, and it should pop over here somewhere. There it is, right there. Just so I can, there we go. Yay, desktop app of Reddit. With the icon copied in there too. It's, yeah. All right, AnyBar. So I'll go out of full screen mode. Oh, into full screen mode. So AnyBar is it's a little utility. You can get it yourself just through Brew, and I really love this thing. It's just a little dot that appears here at the top, and you can change it to any color you want, but you can program it yourself. So like I used it, I wrote a little utility for myself, which was like if you're running a long script that can sometimes fail, I call it with _AnyBar, and then if it fails, I get a thing that I can see it versus having to go back to the terminal and see, oh, it failed, now I got to rerun it again, so I'm not waiting really long periods of time. But to make it more real, oh, I forgot to show you the Electron code. I'll jump back to that. All right, so I guess you can kind of see it. All right, there it is. All right, it's green, right? Right there. OK, Google, talk to Health Tracker.
Sure, here is the test version of Health Tracker.
Hi. I can track your calories. How many calories did you eat?
1,500.
Alert. Getting close to your caloric limit.
That was one thing, but it also turned orange, if you can see. It's now, whoops. OK, I'm doing that. It takes too long. We'll just use this thing.
Alert. Getting close to your caloric limit. Alert. Getting close to your caloric limit. Dude, stop eating.
Right? So I'll jump back for a second to the Electron code. Again, the purpose of this is to show you that it's really easy. Or I maybe show it to you. Super easy, very similar to before. The AnyBar code, let's shut this down because it's going to annoy the hell out of me otherwise. This is the entire file, the 20 lines. I actually just extracted away the Firebase stuff to a different file line too, but otherwise we require AnyBar. We make sure we can run a process because I can call the say command. But lines 12 through 19 are really where pretty much all the work happens. And if calories is less than 1,500, it's green, AnyBar green. If it's less than 2,000, AnyBar yellow. And if it's greater than AnyBar red. Any questions? All right, hopefully these code examples are pretty obvious. Productivity stuff. All right, this is one that I added really late, and I just realized it seemed so boring that it actually was so cool because I didn't expect to be able to do it. So Microsoft Excel is Microsoft Excel. Normally, the way that if you worked in a big company, if you're doing financial stuff, for I don't know how many decades or whatever, you use what's called VBA to write code that can actually automate Excel stuff, right? Especially in sort of business applications. That hasn't changed in years, right? But you'd be surprised. It's used in, I'd imagine, like half the code that actually runs in most Fortune 500s is some business person writing VBA or some semi-technical person writing VBA, or it's a developer writing VBA. Well, what's the other language they added? In 2013, Office added support for JavaScript APIs. Not just web, desktop and web. And in 2016, they added a whole bunch of new features that actually make it like real, like make it most of the stuff you could do to automate Excel and Word and all that stuff using VBA, you could do in Excel. You can do in JavaScript now. And if you ever have an issue where you want to automate stuff in Google Apps Script or in Google Apps, your Google G Suite, whatever they want to call it, they have their own language called Google Apps Script, which is essentially a variant of ES5 JavaScript. And you can use their editor, and you can essentially automate things inside of Google Apps, like move data around, et cetera. So let's say that we've put in some data into our health tracker now, and we're like, we really want to analyze this. We need some big data analysis, some science. Oh, by the way, I'll show you this to you. I'm not lying about that JavaScript stuff. It's real. That's really what they're pushing now. It's not. And again, Google Apps Script, very easy. It is what they say you should write if you want to do any sort of automation in sort of their cloud productivity tools. Am I moving too fast for anyone? Too slow? Not too fast. OK. Yes?
On the Google Home, how is it delivering your voice input? How are you checking it?
So in terms of like, how does it know that I want to talk to my app?
How does it know what you say?
So Google is taking care of that part, right?
How are you checking
Oh, okay. That's a good point. I'll jump back to that in a second. But essentially, you have to declare like a manifest file when you upload called an action.json, which is where you say like, if you use my trigger, this string pattern should match like this callback, and this string pattern should match this callback. And then inside those string patterns, it's not just hard-coded strings. You can like input like variables, or like this is a placeholder for a number, this is a placeholder for a date, and they use their wizardry to like take all the various formats that someone could say a date and put it into the right place, so that when you get it, it's sort of in a standardized format. Actually, they'll parse those variables out and just give them to you on the side with whatever name you gave them. So they're like using their AI wizardry to help you a ton. I don't believe Siri has an API that is open to the public at all. I think it's only for like specialized partners that you have, unless, I haven't looked into that, but I believe that's still the case, that you have to be like a preferred partner at like an Uber or someone like that to get access to their API. Does anyone else know anything else about that? No? Yeah. Yeah. They have a similar pattern, but they do have a different setup. Where I know with Google, you're essentially declaring this manifest file you give them of like, here's what I want you to tell me about stuff, and here's what callbacks I want you to hit, and then you run your own server somewhere else. Versus with Alexa, like they're pretty prescriptive that they want you to write in a more specific way, and they want you to put it on Amazon Lambda. Lambda as a service, AWS Lambda. But I did not go as deep into that because I don't own one. So I could be wrong on some of that. Anything else? Or what? OK. So let's say we've got months and months of data, and I'm like, I want to know what's the average number of calories I've eaten per day, right? That's a pretty reasonable thing to want to know. Well, I could very easily, so I wrote this little integration. You can see I've already loaded it. On the top right, there's a little health tracker button, right? And the way you get to that is you go to Insert, Office Add-ins, and you can load your own your Microsoft JS add-in, which again, they've even written like their own Yeoman generator for. It's amazing. So I click this, and this is running locally on my machine, and I hit run, and boom. I have now imported all the dates and all the calories, and I can do is it average? This is not my specialty. 2001 calories. Woo, right in the dot. OK. So the code for this, again, and by the way, this is running in Office Online. You can run it on desktop. Well, OK, it's not true. You can run it on Microsoft Office for PC, but they have not updated Microsoft Office for Mac to run add-ins yet. Just the Microsoft way, I guess. So I'll shut this down. So it's very, very similar once again, but you have this run function that they include in the boilerplate. Line 16, we get a reference for the spreadsheet. Line 18, we're retrieving Firebase data stuff. We get all the data, and then we essentially just use some stuff to say, like, hey, I want you to take this array of arrays and put it into this range, which is essentially the range that we have in the spreadsheet. And then when you do return context.sync, it actually executes and actually does all the inserts into the table, into the Excel table. So like, I would have hated looking at this in VBA, but it's really not that bad if you're doing it in JavaScript. It's actually, I would say, easier to do it in JavaScript than to do it in the older, traditional way of doing it. All right, AppScript. Oh, already did the import here. Let's make a new spreadsheet. Again, super easy. You guys can do this if you use this at work. Go under Tools to the script editor. Wrote some stuff. This is even simpler code, if you can't see. We get the Firebase data. We get stuff. Line 5, we get the sheet. And for I in data, sheet.append row. That's pretty much all we're doing. If I run this, yay, now the second spreadsheet also has all the data. And I could do the same thing there. Cool. Mobile stuff. All right. So this has been around for a while. You've been able to, in some form or fashion, use something like at the bottom you can see Cordova, PhoneGap, Ionic. Those are all tools where you could essentially take a web page and wrap it inside of what looked like a mobile app and run it. Ionic is the one that makes it the easiest. But there's always been a little bit of, these are not really for people that want to write really good apps because the performance was never quite that great. And there's always some jankiness because you are just running a web page as an app. Well, there's a lot of new tools now. One of them is React Native. And that's a mobile framework that lets you write essentially native performing mobile apps using JavaScript. And they do a whole bunch of stuff behind the scenes to do that, but they're running like pretty much device native performance. It was invented by Facebook, used all over the place. And I don't mean this is not React. React Native is being used by Airbnb, Bloomberg, Wix, Facebook, Walmart, Tesla. So it's got some big names behind it, and people have put a real stake in it. It's a real production-ready tool. Again, React Native, real, I'm not lying. I tried giving this talk once, and people just didn't believe me. So I was like, all right, well. But those were boot camp grads, and I had to put all these in because they were just like, it's not that easy. I was like, yeah, it can be. So, all right, demo and code. Oh, crap. Emulators take forever to boot. Oh, no, it's so big. OK. Sorry, Chris, you're going to have to edit that out. Well, I think it's going to work, but it's going to be super big on the screen because of the way the screen renders. So again, similar UI. And this is actually, again, bound to the same instance. And we're doing almost the same thing. But it's a real app that's not running in some sort of wrapper and is running on the iOS simulator. So where's the, yeah. This is, again, the code. This one's going to look a little verbose just because of the way that React Native works. I put the utility functions at the bottom here inside the render function, which you'll see under the return stuff. It's going to be a little bit jankier. But fundamentally, we are using about 130 lines of code, although I didn't separate out the Firebase stuff in here. But at the end of the day, we've got this little thing with a view. We've got the increase button. This is some of the styling, because in React Native, you inline your styles. Button, on press of the button, update current Firebase calories, current calories plus 25. We show the current calories, because we're binding it right here. Decrease calories. We again have a button, update current Firebase calories, calories minus 25. Most of the ugliness here is probably just me being really bad at this. So it's, again, super simple, something that you can kind of grasp. You could probably write this in a day if you spent your own time on it. Mobile, Internet of Things. All right, one more cool one. So how many of you have heard of Arduinos? OK. So it's I would say, the most popular low-cost electronics platform for do-it-yourself projects when people build all sorts of like contraptions themselves. You've probably seen some of those on the internet. It was made in Italy in 2005. Again, the most popular. And kits are super cheap. Like you can buy a kit like the one I'm going to use today for less than 50 bucks. I think I paid 40 for it when I first got it. So Arduino, again, real. You can use it. Well, we're going to be using a library called Johnny 5. And it's essentially a way to interface with the Arduino. But pretty much every language has an interface to the Arduino. I would say the Johnny 5 is the best one by far. It supports literally every board. The documentation physically shows you, like as an image, where to put the pins in. Yeah. If you even want to look at the API, they've got, for example, if you were like, I've got a GPS. What do I do with this? How do I plug it in? They tell you what it's going to work with. And they even tell you how to run the wires, right? So when I mean production-ready, battle-tested SDKs for what their use case is, in this case, DoItYourself Electronics, JavaScript is sort of unparalleled. So, all right, if you can't see, I've got my little Arduino board plugged in right here. And we start it up. It's listening. And if we go over to our dashboard, I've got 2 buttons on here and 2 lights. One of these buttons should be up, one should be down. Yes, they do work. So I can hit my little physical button, and I can change my calorie count. Again, I'll show you real quick. There's a button.js file that I wrote, and it's super easy. We require Johnny 5, we declare a board, we create a button, and this 2 and the 7 are just the pins they're plugged into. And then the rest of it just happens down here on line 28. When you hit down the up button, I'm logging a message and then changing Firebase calories by 25. When I hit the down button, we log it again, and I change the Firebase calories by -25. That's really it. The only other parts are the stuff that lets you connect to Firebase and make updates to the database. All right. Told you, we're going to stretch it here, OK? So most of you have probably seen the crazy gizmos in people's heads where they're like walking around and they've got like the sensors and they can like play games and stuff. And that seems like crazy game development stuff, right? Well, there's actually a project picking up a lot of steam called WebVR. So you don't have to distribute packaged apps through Steam or whatever. You can literally plug the Oculus Rift or whatever it is into your computer, go to a web page, and then play a game. Like it's still a bit immature, but it's getting there. And it's Chrome's on board, Firefox is on board, HTC to an extent is on board, Google Cardboard is definitely on board, the Rift is on board, and there's now a pretty good library that's sort of people are centralizing on called A-Frame. I would still say that if you're truly serious about this right now and you want to get into it, you should probably go and just learn Unity or Unreal, which are the 2 engines that most game makers use. There's something called Unity Script, which is a JavaScript variant that you can use to write some games. People don't really use it. It's really, C# is really king here. But in the interest of stuff, I'm not going to go through these links. We'll just do our demo. Oh, there's also React VR now, which is an official Facebook project. Yes, but in 3D. We can move away from it and back. And this is really bound to the real thing. We can actually change our calories, and it'll go down, and then it'll become smaller, and at some point it'll stop being orange, or we can go really high and gotta click a lot and make it red. And this is, again, in a 3-dimensional space where I can move around and decide to see my calories for really no reason in a 3-dimensional way. And the code for it, like I said, is not really that much rocket science. So I'm going to extrapolate a little bit here. There's a couple of static functions that just, if you don't know what those are, don't worry about it. They're again like sort of utility functions, but the real magic happens in render. So A-frame down here, there's a few things I use, but there's text, light entities, entity. These are, if you're not familiar with React, some of this looks a little bit foreign, but it's really not super complicated. In fact, I'd say honestly most of this is copied from the getting started, so it's definitely not that complicated. And all in all, it's about 116 lines of code. Honorable mentions to wrap up. These are some things that you could maybe do, but they're not really in the wheelhouse yet. So if you wanted to really go into machine learning / data analysis, there's nothing inherently great about Node and JavaScript that makes it good at this. But there's really some cool stuff going on in terms of image processing, just because it's easier to do that in the web sometimes than the client. Game development, there's great gaming engines if you want to build stuff for the web, like web-based games, because that would make sense. But if you want to do console-based gaming, C# is still, again, pretty much the king. And the 2 most popular game engines, Unity and Unreal, have pretty weak support. And finally, 3D printing. So normally, you don't program 3D printing. You like sort of declare it, like use AutoCAD or whatever, right? But people have gone to the extent of where Microsoft has a project now called Maker.js, and there's something called Auto.js CAD, where literally you can print things in JavaScript. So I created, I'll show you in a second, I used Auto.js, or Open.js CAD, sorry, to just decided to print some text, went to the local UPS store and said, they gave me this thing called an STL file. Can you print this? And they were like, sure. And here's these physical letters now, H and T for the health tracker project that we've been talking about so far. So again, Maker.js, really cool Microsoft project. It's all based on what's called OpenJS CAD, which is what I just ended up using. And like you literally are writing code here on the right, like cube, sphere, and you have made stuff. And this all exports to stuff that pretty much all 3D printers can print. You did it all in JavaScript. All right, Mitch, I'll show this one. Tesseract.js. This is optical character recognition entirely in JavaScript. So really, really hard computer science problems are being solved, guys. Really, really hard computer science problems. All right, that's all. That's all I got. Any questions? And I may have run a little bit long, maybe? Yeah. We had a few. Yeah, go ahead. Are you talking about TypeScript?
Well, not so much TypeScript, but like Go.
Go? Yeah. So JavaScript has the inherent advantage in that there's just nothing else that runs in the browser, right? So like even if there's, I mean, you could say for a couple decades now there's been languages that have been better, but JavaScript sticks around one because there's really no alternative to it, right? Because it's sort of all the browser runtimes are designed to run off of it. So Go would be really great for a lot of server-side use cases. But I think, here's why I think JavaScript always has inherent benefits to some extent for use cases where it could be useful, right? One, the open source community and the culture around it, I don't think you can really replicate. Because if you think about it, back in the day when you didn't have server-side JavaScript, everything was front-end, and so everyone was shipping their source code on every page load. So everyone gave everything away, and that's why there's so much open source stuff. Like, why would you hide it? Because anyone could read it off your web page. So that culture, I think, has continued and made JavaScript more vibrant in some ways than a lot of these communities. Two, it's a really flexible language. And three, you've got sort of the critical mass of developers, right, and the browser lock-in part. So I think for what JavaScript does well, and JavaScript could do, I think it will continue to expand. But if you're doing really low-level data analysis or something maybe where you want something that JavaScript can't provide, I think you're going to see people obviously not choose it, right? Like you can't really do some low-level C stuff in JavaScript. If you have something like Go, oh, sorry, go ahead. You had a question?
Well, yeah, there's part two to that.
Oh, sorry, go ahead.
What's your simplest way to get over like the single grade nature, like you making know about it?
Yeah, so I think obviously there's people that are like really good at understanding Node that could answer that question really well. My understanding from some of the stuff that I've been listening to, especially from people that are on the Node project, like they don't believe that's a huge problem. Maybe it is, but at least to their perspective, it's not a huge problem. Because they believe that the problem is actually asynchronicity and the fact that they solved that better versus the fact that it's going to be occupying, that you're never going to really have to occupy a single computing thread. I don't agree with you, but I feel like that's, yeah, go ahead.
Never block the thread.
Yeah.
That's the basic rule. Never, ever block.
Right.
Do that, you can run lots of asynchronous tasks simultaneously.
And that would be the argument that I've heard the people who work on Node say, right? And so this is probably one of those where like I think really smart people could debate it and talk about it for hours. So it's a really good topic, but I don't know if I'm really the best person to answer that question. Mm-hmm. Anything else? That's it? Okay. Oh, no. Okay. Thank you.
I'm good.